Okay, so this is a second little video on organic chemistry. The first one we looked at was naming alkanes, so if you haven't had a look at that, make sure you do so. The video link is there. So just going back on alkanes, so here's an alkane. We've got pentane, so the longest chain here we've got 1, 2, 3, 4, 5 5 carbons long. Okay, so that's the longest chain, is 5 carbons, and so therefore it's pentane, and we know from an alkane that they are only single bonds between those carbons, so therefore it's a pentane. The next thing we're looking at is these functional groups. So this one has a methyl, because it's a functioning group, we call it these are alkyls, so it's a methyl functional group, so that's at carbon 1, 2. And then we also have at carbon 3 an ethyl functioning group. So this one's got 2 carbons on it. Therefore it's an ethyl. So we name this 1, 2 methyl. So that's the name here. 2 methyl. And the next part of that name is there. 1, 2, 3 ethyl, 3 ethyl pentane. Okay, so we should be fine with alkanes. Next one we're looking at is alkenes. So alkenes, if there is a double bond within the compound, then it's within the carbon to carbon bond, then it is an alkene. Okay, so here we've got this carbon here, we've got a double bond. So the way we name these, so first we look at our longest chain once again of carbon. So here we've got 1, 2, 3, 4. So we've got 4 carbons, so we know it's a bute. And we've got a double bond, so it's butene. Okay. Now you also see that you might see these written in this form here as well. Okay, so this refers to our first CH2, which is there. Then we have CH, carbon hydrogen, that's the next one. Then we have CH2 and CH3. So that's a shorthand way of writing the same compound. So this, and the double bond is at carbon 1. Okay, so that's the lowest number that we can find that double bond on, therefore it's 1-butene. Okay. The next thing we want to look at, so I'm going to go on to dienes. So diene is basically an alkene with, instead of 1 double bond, it has 2 double bonds. So it's an ene for an alkene, but it's got di. As we know, di is the number we use for 2. So diene means 2 double bonds. So here's an example of 1,4-pent-diene. So we know that it's pent because it has 1, 2, 3, 4, 5 carbons. We know it's a diene because there's 2 double bonds in this one. Okay, so there's one at carbon 1, the first carbon, and we count across 1, 2, 3, 4. And there's another one at carbon 4. So therefore it's 1,4-pent-diene. The next one we go to, so alkynes. So they all follow basically the same rules as each other. So alkynes, in this case, it's a triple bond. Okay, so here we've got a carbon to carbon triple bond. This one is bute once more because it's got 1, 2, 3, 4 carbons. It has a triple bond, and that's at carbon 1. So it's a 1-butyne. So any of the alkynes end with tyne. Okay, and there's a shorthand way of writing that one. Now all of these, I said all of these including our, we go back to our alkenes are unsaturated. Unsaturated means there's at least 1 double bond within those carbon to carbon atoms. Carbon to carbon molecules, I should say. Okay, alkanes are the ones that are saturated because they're all single bonded. Okay, so you're probably feeling a bit like this, I guess. So when you're trying your best but still dying inside, best thing to do now is either go back over what I've just talked about or have a go at some problems. So let's quickly do that now. So what I'll skip over that quickly. We'll have a look at this example. I'll talk about isomers shortly. This one here we've got pentene. So sorry, butene. So it's got 1, 2, 3, 4 carbons. It's got a single bond. It's got a double bond at carbon 1. So therefore it's a 1-butene. The one next to it, so all we've done here is we've moved that double bond from carbon 1 to carbon 2. Okay, so this one now is called 2-butene, so it's the same, it's got the same amount of carbons and hydrogens, but it's just the double bonds moved from one spot to the next. So what we call these types of types of molecules are isomers, or positional isomers. So this is where you've got the same, if you look at these two, we've got the same number of carbons. So we've got 4 carbons in this one, we have 4 carbons in this one, and we have the same number of hydrogens. So here we've got 1, 2, 3, 4, 6, 7, 8 hydrogens on this one, and 1, 2, 3, 4, 5, 6, 7, 8 hydrogens on this. So the very shorthand, they could be written in the same way as in C4H8. But they're obviously different molecules, so these are called isomers of each other. So 1-butene is an isomer of 2-butene, or vice versa. So that's positional isomers. So that's all you'll need to think about as far as isomers go in stage 1. Alright, so yes, let's have a look at some problems. So what I'd suggest you do is pause the video and actually have a go at these yourself to see if you can get these without help. Okay, so hopefully you've had a go. So here we're looking, first up we're looking at what's the longest chain. Okay, so we've got 1, 2, 3, 4, or 1, 2, 3, 4. So either way we look at it, the longer chain is going to be 4. So if we've got 4, therefore we've got a bute, so we write that down, bute. So within this chain we have a double bond. So because we have a double bond, we call that one butene. It's only got one double bond, so it's a butene. Okay, so if we choose, so we've got 4, 1, 2, 3, 4. So if we just go straight across and look at our carbon line being those 4 along there, we also have this functional group up here. It's a 1 carbon, so we've got a methyl functional group. First thing we need to look at though is this double bond. So we need to pick the number that's lowest for that double bond. So if we count from this side, the carbons, we've got carbon 1, 2. If we come up from this side, it's 1, 2. So we can actually do that from either side. What I'd suggest is you've actually got this methyl group. You want to, if it doesn't matter from either side, you look at the methyl group and okay, that one's at carbon 2. If you come from this side, is at carbon 1, 2, 3. So I would suggest counting from that way. That's what you should do. So this one is, so we said at carbon 2 we've got 2-butene. And then at the front we put our methyl, so this one's called methyl, and the methyl is at carbon 1, 2, so it's 2, so it should get 2-methyl 2-butene. Okay, so we've got that carbon's got the double bond and it's got the functional group. Okay, for the next one we just have a straight line of carbon, so there's 1, 2, 3. Once again we've got 4 carbons. This one has a triple bond, so we have a triple bond. If we go from this side, it's 1, 2. So there it's 2. From this side, 1, 2. So it doesn't matter which way you go, it's still going to be a 2. Now this is a triple bond, therefore we call it 2-butyne. Okay, so that's those. Next. Okay, once again, have a shot at this one. Just pause the video and have a shot at this one, and then come back to us, see what you have. Okay, let's have a look. So this one we need to look at what's the longest functional group we've got here. So sorry, the longest chain of carbons. So here we've got 1, 2, 3. That's a bit, I'll just move that one slightly. That should be linked to there just to save any ambiguity. So that links with that carbon. So we've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 4, 5, 6, 7. So our actual carbon chain should be going up this way. Okay, so here, next thing we're looking at is, so we've got 8. And let's write down here. So 8 is our oct. You write that. Now, this one here, we have at least at least 2 double bonds. So we know that this is going to be a diene. So oct diene. So that's our main name of that one. Next thing we do is we look at this backbone that we've numbered and we go, okay, we go from this way. So 1, 2, 3 to get to the first. Sorry, correct me on that one. We need to base this on the double bonds. So here we should have 1, 2, 3 to get to the first double bond, or we come from this side and go 1, 2, 3. So it doesn't really matter which way we go. So if we go 1, 2, 3, we get to the first functioning group, methyl. We go this side, 1, 2, 3, 4. So we'd probably come from this side and go 1, 2, 3, methyl. Okay, so we have 3. Now what do we have here? We have a methyl. We have 2 methyls here, don't we? So it's 3. 1, 2, 3 methyl. And 1, 2, 3, 4, 5. 3, 5. Now that's 2 methyl, so it's dimethyl. And all we need to put in is where the double bonds are. So 1, 2, so that carbon 3 is that double bond. So we've got 3, 1, 2, 3, 4, 5 is that double bond. So it's 3, 5 octadiene. And there you have it. There's your name for that compound. Hopefully you got that as well.